Welcome. My name is Arvid Moritz. I'm the head of business development at Denkweit. Today, I want to present to you the DenkVision app and how you can create an image evaluation with just 15 images. In this short session, I want to present to you as well what you always all can do with the DenkVision app and what kind of image evaluation you can create with our tool. So let's jump in. At first, I brought to you a small presentation, how IDS and Denkweit work together as a cooperation for you providing a lot of value with image evaluation. And what you can do with it, I want to show it today, right now. So we have the DenkNet. The DenkNet is already in use in different kind of companies with different kind of applications. From image evaluation inspections to drones to something else. You see here a different kind of variety from companies we already work together. So our slogan is, only those who think differently can create something new. And here you can see there's a small defect on this image. And we have the motto, you just need to show it and you can create an image evaluation. So what can you do with the DenkNet? Can DenkNet do matching? Yes. For example, this is a highly complex image evaluation, which is easily and simply implemented, where we find different kind of faults on a circuit board. And we can decide between a cut hole and a circular, for example. And this image evaluation was just created with 21 images. There you have a detailed view as well. Can DenkNet find cracks? Yeah, sure. Like on metal objects with black or white cracks. Here we have solar modules for crack detection. There's another crack detection on a solar cell. Can DenkNet count? Yeah, for example, this kind of metal objects with the rings, and we can differentiate between those objects as well. Can DenkNet read text, OCR? Yes. There are different kind of texts you can just put in our image evaluation in our hub and create your perfect reading text image evaluation to use it in your production or whatever you want to use it. There are some other examples. There's different kind of industrial examples you can see here and even on circuit boards as well. And this is a nice example I like to show from some notes. Here it's a nice example, another great example where you have like the gift bags, which is really read well, or the corn, even like on the left side, the corn is on the right corner, almost not visible, and it's read perfectly. Can DenkNet decide between good and bad? Yeah, this is a good one, and this is a bad one, and this is a bad one as well. And like this image evaluation was created with just 21 images as well. Can DenkNet do tiny things? Yes, we have no limitations in image size. So you can put a big image in and mark small objects like this one. And we can find it even like on really big pictures. Can DenkNet do deviations? Yeah, for example, in this production, we have like anomaly detection, novelty detection, and this is like a deviation you can find to see defects or other materials which is not supposed to be there. And DenkNet, how should I describe it? Yeah, for example, this is a plastic cap, and there you have like a material defect, which is like here shown. And with this, you can find the defects, do an image evaluation, and sort them out. And this image evaluation was created with just 16 images. Can DenkNet distinguish between pixel by pixel? Yeah. For example, those circuit boards, when you want to find correctly the positions and the orientations, you can use this pixel by pixel and get it right perfectly out of it, of the image evaluation. Can DenkNet be blazingly fast? So rapidly fast? Yeah, there example. like, okay, just on an internal laptop with a 5 megapixel image, we have a image evaluation time of 0.2 seconds. Or even really, really big pictures, it's like a high end with 70 megapixels and a dedicated graphic card, we have 0.45 seconds. Can DenkNet do many different classes? Yeah, sure. For example, the German road signs, which you can find here, there are more than 600 classes where you need to decide between, okay, which kind of objects do you have? And we created, or the customer created by themselves, this image evaluation to differentiate between those different road signs. So highly complex image evaluation, simply implemented. This is our motto. And can DenkNet do that for me too? Like matching for small differences, point out cracks, count overlapping objects, do OCR, flexible distinguish something, very small and difficult defects recognizing, search for novelty, distinguish between pixel accuracy. Yes, and we like to motivate you. Okay, do you have images so that you can do it by yourself, or we can show you that is possible. Wonderful. So this is the small presentation I provided to you, what you can all do with the DenkNet and the DenkVision app. There's even more possible when you see it by yourself. And right now, or in the next step, I want to show you how you can do it in our hub. So I do a live session with you to show you how you can do it by yourself. Let's switch the monitor. All right. Here we are in our DenkVision hub. This is the standard overview when you logged in, and you can see on the left side the projects, some networks you're training on. You can quick start with different kind of the technology or use cases, and so on. We also have an education center where you can inform you with YouTube videos, some PDFs, and so on, if you don't know anymore or how you can solve your problem. Today, I brought to you a NUT quality check. So in this example, we have some images of a NUT which has no defects. And I can just upload some images in our File Explorer, and you can see, okay, we have a different kind of good images here. And I also took some images of a NUT with a defect, which I can show you here. In the first example, we did a classification. So we just put a label on the image to say, okay, if it's good or bad. In this case, okay, we have a defect here in the middle of the NUT. And we just said, okay, this NUT is bad. So we said, okay, there's a defect. And then I can continue on and say, okay, this is a defect as well. And as you see here, we have user annotated those images over the defect. The same we did to provide to the good images, so the IO NUTs. We said, okay, there's no defect on top of it. And we say, okay, there's no defect to see. So this is right. And we have this here as well for some example images. And when you mark just 15 images, you can see, okay, there's a green, our green play button. We can just start, and all the complex technology is starting. All the complex algorithm is started, and the image evaluation will be created for you. We did this already, and we can see here already, okay, in this network overview, we have just 10 images in the training and 5 in the validation set. So it's really just 15 images. And we started the training a little bit before. And with a couple of minutes, we have an image evaluation to see if the NUT is good or bad. And this I want to show you. So we had a test data set with random good and bad images. And you see, okay, in the AI annotated, so the image prediction already shows, okay, this is a good image because the defect button is not on. I switched to another images as well. Like here, this is a good one as well. This is a good one as well. Okay, there's more good ones. Oh, there's a correct one. Okay, there's a defect one. And here you can see the AI already said, okay, there's a defect visible there. For example, this one as well. And so on. We have different ones. It's always bad. Go through here. And there's a good one as well, for example. And this is a good one as well here. This is the first option. But we do also very good pixel accurating detection for the defects. So when we uploaded the images and we created a network, which you can just do here, you can choose from different kind of technologies here. And then you say, okay, I want to mark those defects with pixel accurate network. You have like here different kind of tools to mark those defects, which are already prepared for this meeting. And you can easily use those tools like, okay, we have freeform when you have like different kind of objects. I like the sausage one if you have like cracks or something, and you can do like a snake or something and really easily adapt the width of it, and so on. Then we started with just 15 images. I can show you that again. How many images are in those networks? Okay, here just 13 images in total with a defect, 2 without a defect, and we trained I trained a small network for detecting those cracks pretty fast, and have here on my overview in my test image dataset, for example, the options. Okay, there is no defect. This is perfect. There's no defect as well. And for this, there's the defect found with the AI, as you can see. This is just how you create an image evaluation, but this is not how you use it. So, for example, when you have a production of nuts, which is here like the use case, you want to sort them. So you want to decide, okay, I want to have a good bucket and a bad bucket. And therefore, we have different kind of services to provide in the decision center. For example, you create rules for sorting those images. For example, okay, I have a classificator here and say, okay, if it's like more than 50%, I can adapt this as well here to say, okay, this should land in the not okay bucket. And then I can evaluate it and optimize my production in the tuning center. We have like the classification tool and see in my test data set, okay, there are different kind of good ones, there are bad ones as well. And I want to optimize like my decisions and can easily just click like here and change the rules to optimize my quality. I did this already as well for the segmentation, and you can see it here, where we have the good ones here and we have the probability of the bad ones. And there you can easily adapt those. Okay, if you want to optimize it, or for example, from the test data set, you can easily just click in it and change the annotation and optimize it here and mark this as a user annotation as well. All right. And with a network, which you just created, or just by pressing play, you can download it and use it in the production. And you can just use those rules, those recipes, to use it in your production as well. So you have an image evaluation with just taking an image, evaluating it by AI, and then use it with just okay, not okay, in your production setup, wherever you want to use it, to optimize your quality, your production yield, and so on. At the end, I want to show you a nice feature which is coming very soon. This is our one-click annotation tool. So for marking those annotations, the segmentation, for example, it takes a lot of time to be very accurate to find it. So when you want to do it, you can just go like with our new feature, then define a positive point. And I want to find the whole nut, for example, just by clicking it on, and the whole segmentation will be, the nut will be segmented. And save it and go so on. I can do even like, okay, just the middle one, or without the inner rings. define different kind of positive points really easily to optimize it for my use. For a defect one, it's looking like this. Okay, you have like the defects. Can zoom in it here and just press the positive point. Okay, it's complete. Just want this small one and use this annotation for my training. Then I have below a crack as well, which I want to find. Okay, just press a point and it's working. And so you save a lot of time creating those image evaluations by just 15 images and just with a very small one-click tool.
I had one, Arvid, you showed us a really prepared setup. Could you show us quite fast how easy it is to annotate a completely new image? So
yes.
In the DenKap, how easy this workflow is?
Yes, let me just switch to my screen again. All right. So I can start right now, maybe just, okay, I want to start the project. I uploaded my files already. We can do it like in the test dataset right now here. And I want to create a new network. So I choose, okay, like the segmentation for pixel accurate detection. And I want a defect detection, for example. This is it, and just choose a color. For example, this one is blue. Okay, then I have already created. I can go now to the training. And when I would be like here, a new image like this one, I choose my defect detection network, which I just created. And now I have different kind of options to mark those defects. When I start right now, I would just scroll in to the image to really mark them accurately, because the data input is very important, the data quality for a very good image evaluation as well. And here I would use the polygon just to mark, okay, there is the defects. I just click here in the image to draw, okay, there are some defects. And when I'm done, I'm pressing enter. Okay, the first annotation is done. And like there's a hole and another defect from the production setup, for example. Press enter as well. I'm done with marking. I check, okay, there's every defect marked in this image. Just save and next and continue to the next object.
And if I understood right, if I have marked a special amount of defects, this green training button starts automatically and I can start a training,
yes.
Right?
Right now you see the green button on the right-hand corner. It's here. It's disabled because we don't have yet enough image annotated. And we have already one image in the training set. So when I'm here done with it as well, and I have this image is full, then this green button will be lit up. Yes.
And after the first training, I've played a little bit around with it. Also, the prediction starts. So the DenKap Pro tells me what are possible issues.
Yeah. Thanks for this question. This is a very good point, which I didn't mention enough in the presentation. So the process is, okay, you annotate it. And when you have like 15 images annotated, the green button will be activated. You can press it to start the training and continue on the annotation if you want. But you can also grab a coffee or do some other stuff and wait a little, some minutes to wait for the first snapshot or the first solution of the AI, which will be optimized in the longer run. When we have the first solution point, this other button, the auto prediction, will be available, where you can just start then the applying the algorithm of the AI to a new image, for example, and to see how the image is evaluated by the AI. For example, okay, it will be suggest there's a defect, for example, and there's a defect. If it's not, then you can easily adapt those and say, okay, AI, you did it wrong. So you have a very short human in the loop optimizing process to optimize the AI. Or when you're satisfied, you can use those annotations to put it in the training again, or you can just leave it because it's already working the image evaluation to use it.
Okay, thanks. Thanks for joining the session. I wish you a nice afternoon and goodbye.
Thank you very much.